All right.
Hello, guys. My name is Alfredo Deza. I've for the past year and a half or so, maybe a little bit more, I have been in charge of cutting releases for Ceph, and where we started a while ago was with it was originally with Jenkins, but it was done in a very traditional ad hoc setup. And when we started growing and trying to get more releases for different distros and different combinations of these distributions, the things started to get a little bit more complex. And sometimes it was very hard to cut releases. And we would sometimes it would take us like 2 or 3, even 3 days to get a single release out. So there was a redesign of the CI, which is still based on Jenkins. And we did a bunch of work there, which allowed us to quickly and on demand start to get builds out, depending on what were the requirements. So we wanted to unify the whole release process with the development process as well, to use the same tooling, because since it was there was a clear separation of systems. Some things that would work in the creating binaries and repositories for dev work would not apply or would not trickle down to the release process. So there was a disconnect there that caused issues, for example, when adding new dependencies or requirements to a system. So we would find those when we were about to cut a release, and sometimes it was very hard for us to um, to basically work around those. So let me give a little bit of an overview on the current state of gitbuilders, what's going on, and list a bunch of things that we think are current issues that we set up to fix with a new system. So right now, Git builders are, I would say, struggling a little bit to cope with demand. We've grown not only the core development team for Ceph, but also contributors. And right now, Git builders are set to basically build create binaries and repositories for every single branch every single time a branch gets pushed. So that creates a high demand for Git builders, and it is no longer a very small team of people contributing to Ceph, and Git builders being able to cope with that kind of demand. So right now they're kind of slow, again because of the way they're set up, which is basically every time someone pushes to a branch, it will create a build. And there is no easy way to scale that up. The way it works right now is that each Git builder host produces a distinct type of binary. So for example, a Git builder for Jesse, Debian Jesse, will produce Debian Jesse binaries, and everything is tied to the host name. So even our test suites, and test runner, which is tautology, in a lot of places we are parsing host names and trying to interpret the host name or map the host name to a specific architecture and Linux distribution and distribution code name or version, and try to make sense out of it to produce to basically run tests. Again, the load part of it and how to scale is difficult because everything is tied up to this way of getting host names. mapped to whatever specifically the Git builder is building. So it is currently not possible to say, well, we want to add 5 more Debian Jessie or Ubuntu Xenial Git builders. It's just everything goes to a single specific host. The other thing is that Git builders, even if that was a possibility, setting up a Git builder is very, very tricky and time consuming. A lot of the process is very well documented. There are some spots where like it's just kind of difficult. It's a lot of moving pieces, and again, we're depending on host names. So setting them up or replacing them is just a very time-consuming and tricky process. And the other thing is that although there is some automation, we rely on most of the time to SSH into a Git builder, make some changes, try to get the build passing, and move forward. So that's very, like we don't want that. It doesn't scale. Like it's difficult to communicate changes like that. We want to be able to automate everything and get everything done in a transparent way that is clear for everyone, not just whoever got into a host and did some work to fix it. Fatal conditions on Git builders is also a problem because whenever a Git builder is down, you're basically left without binaries and repositories for whatever branch you're trying to test or consume. So fatal conditions are basically mean let's either go and fix whatever is wrong with that machine, or try to create a new one and get a DNS mapping for that new host. And those are very, very time-consuming operations. I mean, even if it was a new host, then not only you're waiting on changes or setting up basically a Git builder machine, but you're also waiting on DNS to propagate if it's a new IP. And if it's fixing it, well, however long it takes to fix a given Git builder. So fatal conditions are pretty rough. Now, so we already have the CI working for us. It has a bunch of features, and accommodating the Git builder style of workflow is non-trivial because there are certain things that we expect to happen. One of the things was to be able to communicate or provide an API to communicate the current state of a repository or a build. So I think right now, although there are some flags when you're running tutorial, you can say try and get me the latest builds for this branch. Usually, or before that, it was just not possible, in a lot of test failures where I could not find a repository for this specific SHA-1 on this branch. So what we wanted to do was to be able to accurately provide the test runner or whatever client to say, give me the repositories available for this branch, optionally pass a SHA-1 and say, give me repos for these Linux distributions and these Linux distributions versions or codenames. So that was critical for us. So that way we would either return everything meeting the constraints if they were available, or basically tell you that those repositories are not ready because you're giving us constraints that the system has not been able to produce yet. So that was one of the main things. Now I met with Greg Farnham and Sam, and to discuss a little bit of like what, from their perspective, what was it that they thought is the biggest problem. And the biggest problem, or not the biggest problem, but the number one requirement was speed. Git builders are pretty slow to produce binaries, and sometimes they're spending hours waiting for builds that may or may not come, and you really don't know that the status of the build system. So one of the number one requirements was like make it super fast. And so right now, where we are at right now is we're almost as fast as as long as it takes to produce a set of binaries. And for Ceph, I think in Jewel we're looking at roughly an hour from the time that we create a request to build a specific branch, all the way until that repository or repositories are ready. So I would say that's pretty fast, and we're able to scale that pretty easily because we're relying on the same mechanisms that we're using for the release system. And the way that works is we don't provide, or for the most part, we don't provide any static build nodes for Jenkins. Most of it, I would say 95, 98% of all the Jenkins nodes are created on demand. So a request for building something will come in, and if there are machines available, Jenkins will just send those jobs and will distribute them to a bunch of builders, and those will be in charge of producing the binaries for whatever distros and architectures and distro versions or codenames are required. So there's a system, there's a small service that constantly is poking at Jenkins and seeing if it needs something. And if it does, it starts firing up these machines on the fly and make them join the Jenkins pool of nodes to start creating or working, doing basically work for the builds. And when those are idle, it terminates them. And it usually takes like 10 to 15 minutes to terminate them if they're being idle, not doing anything. So this elasticity is very convenient, and it allows us to fully provision everything with automation. Like there's no one right now behind the scenes saying, "Oh, I think the load is kind of high. We need to get some nodes in." It's just everything is just automatically extended and contracted. So that's very convenient. So the load, there's also load balance for the repositories. We've just discussed the scaling from the Jenkins point of view, but Jenkins and Jenkins nodes are just producing binaries. The repository production is delegated to a different service. There's a service that is an HTTP binary API, and when Jenkins nodes are complete with the producing binaries, what Jenkins will do is will start sending these binaries over HTTP to this remote system. So the way we load balance this is by first of all, we don't have just one or single HTTP binary API. We have multiple. So at the beginning of a build, Jenkins will say, or each Jenkins node that it's dependent on a distinct Linux distribution and version and architecture will say, it will talk to the reporting service, which I will discuss a little bit further along. But it will talk to this service and it will say, give me an HTTP binary API that I can use. So this service will have a pool of these nodes and will will provide you with we're using round robin load balancing, so it'll provide you the one that was least used, or the one that is basically in round robin fashion, the least used, or the one that was last to, not the one that was last, but not the most recent one. And it will return that. And before returning, which is, and this is one of the coolest features, which is hit this issue last week, before returning that to Jenkins, before saying, hey, like this node, this binary HTTP service it's the one that you should be using. It does a health check. So all of these binary APIs, they have like a health URL endpoint, and Jenkins will the reporting service will go and check this URL, and if it's healthy, it will return it to you. So if for whatever reason this thing is like having issues, or there's the database is down, or some of its core services that are needed to run are not okay, or even if an administrator went and took the application down, it will skip and try to return you something else. So it's not only load balanced, but it's load balanced with a health check that is done on the fly as the build is about to start. And it will use this pool of resources to like give you another one. So if we have 3 or 4 or 5, that will happen. So this way, repositories are not tied to a given distribution or distribution code name, or even architecture. So we can have 10 of these if we want to, or 20, and scale them up and be able to serve more repositories and load balance repositories as well, in the sense that right now, for example, we might be seeing less. I don't know if we still have gitbuilders for Debian WYSI, but I'm sure like if we have it around, that that gitbuilder is probably not seeing much action. But this way, we are depending on what is being requested. It doesn't matter, because we are just going to use all the HTTP binary APIs that produce repos, and we're just going to spread the load around. So there's not going to be one hot server unless unless, well, basically the other ones are out of rotation. And also very important for this is like whenever an administrator goes and says, oh, well, there was this problem, the database server was down, or we needed more disk space, as soon as it boots up, this binary API will say, will perform all the health checks. And at the end of that, we'll say, oh, yeah, I'm healthy, so I'll send a callback, an HTTP request to the reporting system and say, hey, you know what? I just got booted up, and I'm healthy. This is my host name, and you should add me back to the pool. And so, like, from the administration point of view, that's very cool, because it doesn't require restarting systems or trying to do anything manually. Your job is to just get this one system going and working and getting in a healthy state, and bounce it or start it, and then it will join the pool. And this is the same thing for new hosts. So tomorrow we decide to add 2 more. We don't need to change configurations or edit files and restart systems. We're just, as soon as these things boot, they are going to auto-register themselves to the reporting system, which in turn will use it to send the host to the Jenkins nodes. So this reporting system is called Shaman, and it is in charge of doing a couple of different things. So one of the things it's doing, it's providing an API that collects information on what's the status of a given repo. So along the way, when Jenkins is producing these binaries, we want it to be very, very clear, or to like understand with a lot of granularity in what in what part of the build process we are currently at. So when the Jenkins job is done, and it has posted all of the binaries, he tells the binary API, I'm done posting binaries, you should start creating the repo. The binary API will send a call back to the reporting service. It will say, hey, by the way, I've been asked to start building a repository for this distribution, this version, this architecture. This is the URL that the repository is going to be leaving. And throughout that process, it starts at getting, it's requested, then it gets to a point where it gets queued. We have a queue system to be able to cope with synchronously with multiple different builds at the same time. It gets on the queue, and then it gets processed, and then when it ends, it's like it says it's ready. Or if it doesn't end, if it finds there's an error, it will report there's an error condition. So that's one of the things that this thing does. And eventually, what we want to do is to provide for this to be able to be the main status page where any person can check it, what's the status of a given build for whatever distro or architecture and whatever branch or SHA-1, and to feed off of that knowledge of the status of the build. And we can keep adding more and more as we see convenient. Right now, we just have the status of the life of the repo from the time it's requested all the way until it ends. The other thing that it does is, like I mentioned, the load balancing. So it receives the things from the binary APIs when they're healthy, and it provides them to a client, which in this case is Jenkins. So Jenkins is saying, give me a host where I can push some binaries. So it will know about the pool of hosts. It will do the health checks on these systems, and it will update accordingly the pool whether a node is healthy or not, which I briefly explained a little while ago. And that's right now where we're at with those things. And the last thing that we've added to this is the portion where we provide for a search API here that clients like Tautology will be able to ask for. Hey, give me the latest repo for repos available for CentOS 7 and Ubuntu Xenial. And for this branch, for this project, well, it's mostly going to be Ceph, of course, but we're also allowing other projects to be able to be accommodated easily. So you specify the project, these distributions, the Linux distributions that you want, and the architecture, and either a specific SHA-1 or just request the latest, and it will return the whatever is available matching those constraints. So that's huge, I think, for something to like Tautology to ensure that when at test time things are available and ready to be tested, not just relying on some value that might or might not be correct. And again, all of this is fully automated. All of the systems that we've discussed here are 100% automated. There are some things that require a little bit of manual interaction, like the Jenkins master server requires a little bit of manual configuration. But most of it is fully automated. Upgrades or changes to the code bases of all of these different systems are automated. So we're just pushing buttons here and deploying and making them restart. And we're extremely happy with that because we've been able to make so much progress and so fast, really, and keep deploying these things as soon as we feel confident. This is just a very, very, very simple graph on the things that I described. So we started at the very left of the slide where the Jenkins job is started. That fires up the different build types to the Jenkins nodes. that are brought up on the fly. If they don't exist, if they exist, they get reused. When those Jenkins nodes are done, they push they post these binaries, these files to the HTTP binary API, which is called Chakra. That's the application that produces the repositories, and then it posts, Chakra in itself posts its statuses to Shaman, which is the repo status API, so to speak. And then Tautology just consumes stuff from Shaman. Now, Shaman, when Shaman issues the reporting back to Tautology, it includes obviously the URLs for the repositories it needs to use. So eventually, Tautology will just pass these URLs that are living in any of the Chakra instances to the test suite. So you will be able to consume those. So this is roughly the whole system. I didn't want to go into too much detail in trying to give an overview of what the problems were or are with the Git builders, and what things we've tried to improve and fix, and in hopes that it will be a very cool system again. Right now we're at a point where everything is deployed and we're running and creating builds and actually getting repositories and seeing things work. So we're basically almost there with how this is all working. And that's it. That's the presentation. Does anyone have questions? You can put them in the chat as well, or just speak up.
So if this is all working now, then when are we going to start actually using it for our nightlies?
Yeah, well, it's all working. There, one of the missing pieces is the tautology portion, and SAC is going to be working on that. So for the tautology part, what we wanted to do is not make tautology work until everything is absolutely 100% correct from our point of view, but we wanted to get documentation on how the API works, and basically do a couple of feedback sessions with Dan, Mick, and Zach Sursa about, like, what do you guys think about these APIs so that tautology can consume these. And that's what we've done. And like basically we're at a spot where we're just waiting for that to be integrated. The documentation is finalized, and we're providing all of the functionality needed. Any other questions?
What about the wait until this particular SHA or this particular branch is ready type of functionality? Is that part of tautology integration, or because I imagine tautology would need to like subscribe for some kind of a push notification thing, right?
Yeah, so we don't have any push notifications. What we have right now is we're providing a search API where you can say, given these constraints, give me a repo that I can work with, or repos that I can work with. So I would say that right now that looks mostly as a tautology implementation. So I'm thinking that it will just keep retrying to see if that repository is available or not, and then make a logical decision on to either drop the test suite because the constraints couldn't be met, or continue But like, I don't know, that's more like a tautology implementation part. We're just trying to provide these things as fast as possible and tell you what's available. Any other questions? Nope. Okay. Well, thank you so much for spending a few minutes to basically understand how these things are working. I'm pretty excited about this work. Things are very way more resilient. We're able to scale up, and I think it's going to hopefully make a good impact on how we develop and provide repositories for development consumption. Thank you.
Thanks, Alfredo. Hey.